number 15 and the problem is 3 sum. Okay, and the statement is we are given an integer array that is num, and we need to return all the tuples. That is, you can say this is a number nums of I, this is another number nums of j, and this is another elements nums of k. Okay, so basically we just need to return these tuplets, okay, such that I and j both the index are different, I and k these two index are also different, and j and k these two index are also different. Okay, and basically these three tuplets need to give us 0. Okay, so summation of these three numbers should be 0. Okay, and notice that the solution set must not contain duplicate tuplets. Okay, so you can see the result like I and j should not be equal, I and k it should not be equal, and j and k should not also be equal. So basically we need to find such triplet so that this three are okay unique. That is the thing. So basically we need to find the unique triplets. Okay, so you can see also the example. So you have this array. Okay, so this is not at all sorted, so you can see this is an array. So basically we need to find such three elements that can give us 0. Okay, and all the triplets should be unique. So you can see this 3 gonna give us 0. So basically -1 gonna give us -2, and this 2 gonna give us addition of this 2 gonna give us 0. So this will give us 0, and this will also give us 0, and you can see that this answer and this answer are different, so all the answers should be unique. That is the thing. Okay, now let's analyze this example to find out some approach. So example we just want to analyze to find some solution. Okay, so you can see this is the example. This array is not sorted, and it also contain minus and positive and negative value also. So what I need to do, we need to find three tuplets, I mean three elements from this array, so that we can form 0, right? So that this three element can give us sum as 0. So the very first approach or very brute force approach that can come up to your mind is probably we can use three loops to solve this problem. So basically our outermost loop, let's say outermost loop will start from 0th position, and then we'll be taking another loop that will start from, let's say, first position, I mean 1 position, and we'll taking another loop, okay, third loop that will start from second position. Okay, so probably with this three loop, okay, with this three loop we can able to find such three numbers that will provide sum as 0. Okay, so basically we just need to find whether this sum of these 3 points are going to give us 0 or not. So basically what we'll be doing, we'll be taking three loop, right? So let's say the outermost loop will start. So for outermost loop, okay, I'll start from 0 and up to n minus 2. Okay, up to n minus 2, and then we'll be taking another loop. Okay, then we'll be taking another loop. Okay, for that loop, let's say will start from I plus 1. Okay, it will start from I plus 1, and it will go up to n minus 1. Okay, why n minus 1? Because we also need to find another elements, because we need three elements. So we'll find one element using this, another using this, and rest one using the innermost loop. So let's say we're having another loop that will be nothing but our innermost loop, and let's k, and it will start from j plus 1. Okay, it will start from j plus 1, and it will goes up to 10. Okay, so using this three nested loop, you can see we will able to find three such elements that gonna give us 0. Okay, when we encounter this such elements that gonna give us 0, then we'll simply store that three elements into our resultant array or list. Okay, to return. Okay, that is what we can think of very brute force way. And obviously they're gonna this algorithm or this approach gonna take nothing but big of big of NQ complexity, right? Because we are using three loops, so it's gonna take big of NQ time complexity. So you can say that it is not a very good approach or very good algorithm to solve this problem. We need to think something else or something other approach to solve this problem optimally. Okay, so let's think another approach so that we can solve with very lower complexity. So first of all we can think of two pointer approach. Okay, so but the main problem is we can only apply the two pointer when the array is sorted. So you can see this array is not at all sorted. So first of all what I need to do, we need to sort this array. Okay, to apply the two pointer approach. So we'll be sorting. If we sort this array, it will take what? It will take n log n time complexity, right? N log n time complexity. So it will be taking n log n time complexity to sort this array, and if we sort this array, we'll be getting the result as first of all this -4. Okay, so first of all this -4, then -1, then -1, then again -1. Okay, then we'll be getting 0, then 1, and then finally 2. Okay, so this will be our sorted array. Okay, if we sort this will be our sorted array. Okay, Now what we need to do, we need to apply the two pointer approach. Right now you can see this is sorted, so we can easily apply the two pointer approach. So right now we'll be applying two pointer approach, but there is one, there is one tricky also. Now if we apply two pointer approach, so using two pointer we'll be able to get only two elements, right? We'll be able to get only two elements, and we also need to get another elements, okay, and then we need to take the sum and to check whether we are getting zero or not, okay. So the thing is, we also need to take the another element, okay. So what we'll be doing, first of all, we'll be taking a for loop, okay, to iterate through this array, okay. So let's say for loop will iterate, let's say for loop I, okay. So I'll start from this 0th position till, okay, till n minus 2, okay. I'll just want to write this over here. So we'll be taking a for loop. So for loop, I'll start from 0th position to n minus 2, okay. So you can ask me why n minus 2, because this will work, okay. This I will work as a pass pointer, you can say, okay, or you can say this I will work as a target sum or target, okay, and it can go up to n minus 2 because we also need to find another two elements, right? So that's why it can go up to n minus 2, okay. So let's what we'll be doing, okay, so we'll be taking a for loop that will iterate from 0 to n minus 2, and then within this for loop we'll be using two pointer approach to find the other two elements that can give us zero, okay. So basically you can consider this, okay. So first of all I'll be here, okay. So let me do over here. So first of all I'll be at 0th position, then basically within this part of the array we just need to find the two elements using the two pointer approach, okay. So for the two pointer approach, the first pointer, let's say p, okay, so it will start from here, basically I plus 1, and our last pointer, let's say the pointer will be q, and that will be at the very last, that will be at the last position of the array, okay. So that is the thing. Now using this p and q we need to find, okay, two elements such that this summation of these two and this I gonna give us 0, okay. So basically roughly if we simply consider this I, okay, this value of I as a target, let's say our target is, okay, let's say target, okay, let's say our target is nothing but I. So basically you can see right now what is the target. Right now our target value is 4, okay. So basically what I need to do, we need to find three elements that can give us 0, okay. So we can roughly say that if we find two elements, okay, such that if we find such two elements that can give us the sum, okay, that can give us the sum of opposite of this I, okay. So basically we need to find using this p and q, we need to find, okay, plus 4, okay. And in that case you can see this plus 4 and this minus 4 will give us the 0, okay. So basically roughly you can say we need to find two elements such that this sum gonna give us the opposite value of this I, okay. So right now you can say the value of I is minus 4, so we need to find two value that gonna give us this 4, okay, that gonna give us plus 4, okay. Now let's find this two two element using this two pointer, okay. So right now you can see p value of p pointer is nothing but minus 1 and q is 2, so the sum is nothing but 1. So this is, so our current value is less than the target value. We are considering a value of I as a target, okay. So this is less than our target value, okay. So what I need to do, this is less, so we need to increase the value, so that's why we need to shift the p pointer, or you can say we need to increase the p pointer by 1. So right now p will be here. So again if we check the sum of these two pointers, so you will able to see the sum is nothing but again 1, so this is less value. So again we need to shift p by 1 place, p will be here. So right now the sum is nothing but 2, again this is less than our target value, okay. This is the target value right now, so this is less than target value. So what I need to do, again we need to shift the p pointer, okay. So right now you can see the p pointer pointing to 1, so right now the sum is nothing but 3. So again this is less than the target value, so again we need to shift the p pointer, okay. So right now you can see that p and q are at the same position, so this is nothing but both are indicating the same element. So this is only one element, but we need to find two elements. So what should be the condition, okay, what should be the condition for this two pointer? The condition will be nothing but p should be less than q, right? This much will iterate for this two pointer, okay. So inside the for loop we just need to assign nothing but a while loop, okay. So this while loop, okay, this while loop will be continue till this condition, okay, till this condition. So now we can say that this is the end of this while loop. So just let me first add this first, okay. So okay, okay, now what I need to do, you can see the outer for outer while loop is already ended. So what we'll be doing now, the pointer I will move to here, right? The pointer I will be here, okay. So now what is the target? You can see the value of I is nothing but minus 1. So we need to find two elements that can give us the opposite of this. That means right now our target is plus 1, okay. We need to find two elements that can give us plus 1, okay. And again the for two pointer, p pointer will start from I plus 1. So this is the p pointer, and q pointer will always start from last position. So now let's again do the same thing. So now we'll be checking the value of this p pointer and q pointer. This is nothing but, you can say, 2 and minus 1 is nothing but 1. So this is exactly equal to the target, or plus 1. So right now you can say this I value, this p value, and this q value gonna give us 0. So this is minus 1, this is minus 1, and this is 2, can give us the value 0. So we'll be storing this 3 value. Okay, so we get a value that, so we are getting this minus 1, and then p is also minus 1, and q is 2. Okay, so this is our result, you can say. Okay, so this is the result, you can say. This is going to give us the sum as 0. So we'll be storing this, okay, in our answer. Okay, so this is the result. Now what I need to do, you can see this and this p and q are giving the result. So we'll be increasing the p pointer by 1 place and q pointer by 1 place, because this two value is already added to our answer and we want the unique result, right? So both the pointer will, so p pointer will increase by 1 place and q pointer will decrease by 1 place. Now we again need to do the same thing. So you can see the sum is right now the sum is nothing but, again, 0 plus 1 is 1. So this is giving us 1. So this is similar to our same to our target value, right? So what I need to do, again, this giving us the result. So we'll be storing this result. So I value is minus 1, then p is nothing but 0, and q is nothing but 1. Okay, so this also gonna give us the result. Okay, because if you add this 3 value, it will give us also 0. So this will also need to add to our result array. Okay, now again, p will increase by 1, q will decrease by 1. So you can see this to break that condition. What was the condition? Condition was p less than q, right? While you will continue till until this condition is satisfied, right? So this will break this, so our inner condition will break. Okay, so what I need to do, again, we just okay, just first of all let me erase all this. Okay, okay, now I'll be where, now I'll be increased by 1. Okay, this for the for loop I'll be here. Now again, our p pointer will be here, I plus 1, and q pointer will be last index. Okay, so again we need to find two such element that can give us, so you can see the value of I is nothing but minus 1. So we need to consider the target as plus 1 itself. Okay, so again we need to find two elements that can give us plus 1, right? So right now we need to again check this two value. You can see this two value is nothing but 2. Okay, so this is getter value, so we need to minimize the value. So what we need to do, this is sorted from left, right? So to reduce the value, what I need to do, we need to simply move the q pointer or by 1 place, or we can say we need to decrease the q pointer by 1 place, right? Because from right to left, from right to left, the value are decreasing. Okay, we need to reduce the value, that's why we are moving the q pointer, right? So now again we need to check whether this two value giving us 1 or not. So you can see this two value, p and q. Okay, the sum of these two value is also 1, and this is plus 1, and this is exactly equal to the target value. So we can also need to store this value, but there is a twist. Just let me first store this value. Okay, so the I pointer value is minus 1, and for the p we have 0. Okay, and q we have what, we have 1. Okay, so this is another result, but there is a twist. Okay, so you can see that this result and this result are exactly equal, right? But what you said earlier, we are said that there is no duplicates are allowed, right? We are said that we also only need to have the unique tuples, right? So this value and this value are equal, so we can't we can't store or we can't take this value, because we've already taken this value. Okay, so you can probably for this, okay, for taking unique value, you can probably take a use a data structure that is nothing but set data structure. We already know that set is such a data structure that's gonna store only the unique value. So we can probably use the set value. But yeah, there is another approach, okay, that will be will be using while we're writing the code. Okay, for now let's understand the approach, what I need to do. Okay, so right now we can say that p is here, now q is here. Now if we just, this is getting a value, but so what I need to do, this is getting a value, so we need to increase the p pointer by 1 place and q pointer by 1 place also. So you can see if we increase both the pointer, okay, I mean increase the p pointer and decrease the p pointer, then this will just break this condition. So again the inner loop will end here. So what I need to do, again we need to move the I pointer for loop, right? So right now I will be here. Okay, so what was the condition of I? Okay, I can go at max less than n minus 2. So this is the last position of I that can go, because we need to find 3 elements. This is 1 element and we need to have also 2 elements, right? So this is gonna give us 2 elements. Okay, let's say I is right now here, so p will be here, I plus 1, and q will be the last element. Okay, so now if we take the sum, okay, so first of all let me declare the target. So what will the target for this time? So you can say I is right now, the value of I is 0. So what I need to find, we need to find minus 0, that is nothing but we need to also find 0. Okay, so our target is 0 right now. So okay, so we need to find two such elements that gonna give us 0. Okay, So you can see p and q value. So if we add this two value, it's gonna give us 3. So this is greater than, so we need to decrease the q pointer by 1. So right now p and q both are indicating the same position, but this also breaking this condition. Okay, so what I need to do, we need to break the inner while loop. So basically right now the inner while loop will end here, and again we need to increase the I pointer by 1. But right now you can see that the value of I is not less than this in -2, right? So this outer loop, I mean for loop, will also end over here, and we need to simply return this as a result. So what will be the result? So we are already said that duplicate is not allowed. So this one, okay, so this one and this one, okay, will be the result. So you can see also this is the first result, that is -1 -1 2. This is exactly same as that, and this is the next result, that is -1 0 and 1. This is the next result. Okay, so this will be our approach to solve this problem. So if I right now, if I talk about the time complexity, so you can see that first of all we'll sort this array. So this take what, so let me erase all this first. Okay, so yeah, okay, let me erase all everything. Okay, so what will be the time complexity? Okay, so first of all what we did, first of all is sort this, right? So sort will take nothing but n log n, right? So this gonna take us n log n. Okay, then what we did, we use a for loop, okay, to iterate through all the array. So this is nothing but n, and inside the for loop we are using another while loop for two pointer approach, right? So for two pointer approach, you already know the time complexity is nothing but linear, that is n. Okay, so we can see this is the overall time complexity to solve this problem optimally, and that will be approximately what, this is n log n and this is n square. So summation of this, so we can say this is approximately n square. Okay, now let's code the approach. Okay, so you can see this is actually expect to return a list of integer. So let's make the list of list as a to return the this answer or to store our result. So that will be very simple. We just need to initialize a list of integer, list of integer. Okay, okay, my bad. List of integer, and let's say name will be result, and we can take anything, whether linked list or array list. I'm gonna take array list. Okay, so yeah, this is the initialization. Okay, this is array of array. Actually you can say the list of list to store our answer. Then what I need to do is say that first of all we need to we need to apply the two pointer approach. So first of all we need to sort the array, right? So let's sort the array first. So arrays dot sort, we will be applying this method. Okay, so this is gonna sort the array. Okay. Now we said that as right now we have the sorted array, so we can simply apply the two pointer approach. But we already also discussed that only the two pointer not gonna give us the three elements, because the two pointer will provide us two elements, and we also need to need to have another element. So for that reason we'll be using a for loop to iterate through the array, and basically we are gonna use that for loop iterator, okay, to use the third element, right? So what I need to do, we need to use a for loop to iterate through the array. So for, let's say I will start from 0 and it will go up to the length -2, right? So nums dot length -2, okay, and it's not 3 2, and it will increase every time. Then in between this loop we need to use the two pointer approach to find the rest two element, right? So for two pointer, what we said we need to have two pointer. Let's say the first pointer p, and it will start from I+1 position, right? And the next pointer will be q, and it will always start from the last position of the array. So that will be nothing but nums dot length -1. Okay, and now let's use while loop, okay, for two pointer approach, and the condition is nothing but till p will be less than q. Okay, so this was the condition. Now we need to check whether the three value, that means the value of p, value of q, and value of I gonna give us 0 or not. So the process is very simple, right? We just need to check whether this three value gonna give us 0 or not. So nums of I, okay, plus nums of I, sorry, not I, this will be p, then plus nums of q. Okay, if summation of this three value is equal to 0, then we can say we got the triplets. Okay, and we need to simply store this result, these three elements, into our resultant list of list. But first of all we need to initialize a list of integer, then we need to put that list of integer to this result, right? So let's initialize this. So list of integer, okay, and let's say the name will be a temp or answer. Let's say the name will be temporary. This is temp list, and this will also be of array list. Okay. Okay, now what I need to do, we need to simply put these three elements into this temp list. Okay, so the process very simple. Temp dot, we need to use the add method. Add the first element is nothing but nums of I. Okay, then again we need to put the second element. This will be nothing but nums of what, nums of p, and our last element is temp dot add nums of what, nums of q, right? Okay, nums of q. So we already added this three elements to our temporary list. Now we need to add this temporary list into the result list of list, right? So what I need to do, we need to just result dot add this temporary, right? Temp. Okay, so yeah, that's simple as that. And what I need to do, as we got our result, so what I need to do, we need to increase the p pointer by 1. Okay, and you also need to decrease the q pointer by 1, because we got the three elements, right? So that's why. And by the way, before that I want to mention one thing. You can see this is a lengthy declaration. Okay, so we can use only single statement to do all these things. Okay, and yeah, I want to go with that approach. Actually, I don't want to do this approach because this is very much lengthy and it's going to take some space. Okay, so let's do another approach. Okay, so what I need to do, there's a special method. The name is nothing but arrays.asList. Okay, so arrays.asList. Okay, so this is a special method, okay, that belongs to java.utils.arrays. Okay, so basically this method gonna return us a list. So basically we need to simply pass the three elements into this, okay, method. So the first element is nothing but nums of I, and the second one is nums of p, and the last one is nums of q. Okay, so this is, you can see, this is very simple approach and this is very helpful. Okay, this is very helpful method, so you can use this. And basically it's going to take constant time to do this, actually, to return a list. So yeah, and right now what I need to do is simply need to add this into result. Okay, add this temp. Okay, so you can see right now this is a very simple code. Okay, it's right now it's not lengthy, right? Okay, now let's come back to our code. So what I need to do, we need to increase the p pointer, j point, and j, increase the p pointer and q pointer, decrease the key pointer, because you already get the result. But there is one thing that we need to mention. We already said in our code that we can have duplicate results, but we have said here, you can see that we only need to have not contain a duplicate picture, so we need to have only the unique results. So probably we need to ignore the duplicate elements. Okay, so here you can see we can ignore the duplicate elements. So basically we just need to write a condition. Basically, if we think carefully, we already sort this array. Okay, so all the duplicate elements of this array will be very adjacent to each other. Okay, so if you simply ignore this duplicate element, then we can probably overcome. Okay, we can overcome to have duplicate result. Okay, so there is a condition we need to use. Okay, so we simply need to check that if the current element is exactly equal to the previous element or not. If this both are, if the current element is exactly equal to the previous element, then we need to ignore this element, because this is going to give us the duplicate result, right? So that's why. So the condition is very simple. So first of all, we just need to check whether I is greater than 0 or not. If I is greater than 0, then we'll perform the condition. Okay, and it will be very simple. We just need to check whether the current element, that is nothing but nums of I, if the nums of I is exactly equal to the previous element, that is nothing but I minus 1. Okay, so you can say this is nums of I minus 1 is the previous element and nums of I is the current element. So we just need to check whether this current element is equal to the previous element or not. Okay, if this is equal to previous element, then we can say this can have duplicate, so we simply need to ignore this condition, right? Okay, so what I need to do to ignore to ignore all this operation, we need to simply use the continue, right? Okay, we need to simply use the continue keyword. Okay, so that we can escape all this code and start from beginning again. Okay, so this is very simple. We only need to use this condition, okay, to ignore the duplicate one. Here you also need to use condition to duplicate for the elements, and the condition will be nothing but while p is less than q. Okay, and if the current element of p is equal to the last element, equal to the previous element, right? Equal to the previous element, that will be nothing but p minus 1. If so, then what we need to do? We need to again increase the p pointer by 1. Okay, and again we need to do the same thing with q pointer. So let me copy this. So what we'll be doing, we just need to do this thing, and again this time condition will be same, but it will be q. Okay, if the current element of q pointer is equal to the previous element that it already did the operation, right? So it will be q plus 1, not q plus 1, not minus 1. Okay, so if the current element of q is equal to the previous element, then you also need to decrease the q pointer, because it will also it can also give us the duplicate result. Okay, so this is very simple. Okay, you can see this condition and this condition is exactly same. Okay, so the difference is only the q pointer and p pointer. Okay, so yeah, we already discussed the first condition. Then what the raise to condition? Okay, the this condition is if both equal to 0, then we have other two condition, and the rest of two condition will be this summation of these three can have greater than 0. So we'll be checking this condition. If okay, else if the sum of these three values, just let me copy this first. Okay, so what will be the condition? If this sum of this value is greater than 0, in that case what I need to do, we need to simply decrease the q pointer by 1. Okay, so you can see right now this summation of these three values is greater than 0, so somehow we need to reduce the value. But you can see this I pointer is this is fixed. We can have only reduce this p and q pointer, right? So that's why and all elements are sorted from left to right, so we need to decrease the q pointer by 1. Okay, and else what is the race condition we have? Else the condition will be only one, and that will be this three summation of this three is less than 0. So in that case we'll need to increase the value. Okay, and to increase the value we need to simply increase the p pointer, right, by one place. This is a very simple code, you can see. And lastly, when we'll be out of this for loop, we just need to return the result. Okay, return. Okay, we simply return the result, and result is nothing but list of list. Okay, that you already store here. You can see we are storing this result, okay, into this result. Okay. And simply just need to return this. Now let's run this code to check whether we have some error or not. Okay, okay, so we have some error. And what is the error? Error says can't find a symbol. Why? Okay, the misspell. Okay, typo error. Let's, do we have another error? No, let's take it out. Okay, right now you can see it's working very well. Now let's submit this, whether it's gonna submit it or not. Let's check it out. Okay, so you can see it gets submitted. Okay, okay, it's taking time. Okay, it gets submitted. Okay, so you can see it gets submitted. And yeah, we already discussed the time complexity. And if we talk about the space complexity, then if we you can see that we are initializing this list of list just to store the result. But this is under the this under the condition of question, right? Because question says that we need to return this. So if you simply ignore this output list of array list, then we can say that our space complexity is approximately big of n. Big of n, because we are using this sort method. So somehow this sort method takes big of n space, okay, to sort this array. Okay, and that will be only the space complexity. And we again and already discussed the time complexity, and that is nothing but approximately n square, right? Yeah, that's it.